classifying triangles. So up at the top here, we have our notes. We have a scalene triangle. We have a right-angled triangle. Let's go over back to scalene. Okay, scalene. What is a scalene triangle? It means all the side lengths are different and all of the angle measurements are different. A right-angled or a right-sided triangle. It contains one 90-degree angle. That's the only requirement. If it has one 90-degree angle, it's a right-angled triangle. For isosceles, we have two of the same side lengths. So if you see these two blue dots right there, same side length, and two angles are the same. So the red dots signify the angle measure of the left angle at the bottom and the right angle at the bottom. Those are the same angle measures. And then for equilateral, all of the sides are the same length and all of the angles are going to have the same measurement. So for this first one here, consider the sides of triangle ABC that's shown in the graph here, and describe it either as scalene, isosceles, or equilateral. So we're only looking at three of these triangles. I want to know all the sides are different, all the angles are different, two sides are the same, two angles the same, all the sides the same. So first we're going to look at side length. Okay, just focusing on side length. Then we'll consider the slope to see if it's a right triangle as well. So let's identify the measure or the coordinates of each side. So point C is -2, -5. Point A is 0, -4. And B is 0, -9. So to calculate the side length of AC, so this little guy at the top, we are going to use the distance formula because we have 2 points. We have an x1, y1, x2, y2. So we'll plug that into the distance formula. So we have the square root of -2 is our x value, minus 0 is our second x value. You could also have 0 minus -2. Remember, the order doesn't necessarily matter. And then it's going to be squared, plus the difference of the y's. So in this case, we use -2 first. So for the y's, we're going to use -5. -5 minus -4. And I wrote it as plus 4 because minus negative is the same thing as plus. And then we square it. Okay, next line. I'm going to rewrite that square root symbol. Don't forget that. If you start dropping it, there's a good chance at the very end you'll forget to add it back in. So every single step, you need to make sure that you're writing that square root symbol. The -2 minus 0 is -2 squared, plus -5 plus 4 is 1 squared. Then we'll go through and we'll square those numbers. So square root, again, -2 squared is 4, plus 1 squared is 1. Now we have 4 plus 1 is the square root of 5. And now you can go to Desmos. We'll hit square root 5, and it'll give us a decimal. That is the side length. That means that this side length, let's say we're talking about inches. This side length of AC is 2.24 inches long. Okay, now we need to do that for the other sides as well. Let's look at BC. So this like slanted side here, BC. So -2, -5, 0, -9. So again, we have square root, difference of the x's squared, -2 minus 0, and plus the difference of the y's. So -5 minus -9, which is plus 9 squared. Then we'll do the math inside of the parentheses, following the order of operations. Remember, PEMDAS, parentheses go first. So we have square root, again, write it down. -2 minus 0 is -2 squared, plus -5 plus 9 is 4 squared. Order of operations, next comes the exponents. So I will square both the -2 and the 4. So -2 squared is 4, 4 squared is 16. Again, write your square root symbol. Then I need to do the addition inside of the square root. So 4 plus 16 is 20. Again, go to Desmos. Square root of now 20 is 4.47. So we'll write that down. Okay, now our next side length, we could absolutely use the distance formula. We have 2 coordinates for AB, or since this is a vertical line, I can use these little boxes to count the distance. 1, 2, 3, 4, 5. It is 5 boxes long. So the distance of this side, AB, is 5 units, so 5 inches. Okay, so we have a side length of 2.24, a side length of 4.47, and a side length of 5. If you don't remember what that kind of triangle is, scalene, isosceles, or equilateral, go back and look at the notes there. Since all the side lengths are different measurements, this triangle will be classified as scalene. None of the sides are the same length. Now we're going to consider the slopes. Is this a right triangle as well? So we could absolutely calculate the slope of each and every side, but I think that there's a quicker way to do it where we don't have to necessarily all the time calculate the slope. So grid lines, these grid lines right here, are always 90 degrees. Every single time, 90 degrees. So if this line right here is less than the 90 degrees, I don't really need to calculate the slopes and look at the slopes to consider if they're right triangles or not. It's less than 90 degrees. I don't know what measurement it is by looking at it, but I do know that angle A is less than 90 degrees. Same thing for angle B. 90-degree grid lines, and my line, or my angle I should say, angle B is like this. Definitely less than 90 degrees. So I know for sure A and B are not 90 degrees. I'm going to need to calculate angle C, however, because I can't tell since it doesn't match up with any of the grid lines. I do need to calculate 90 degrees here. And how do we do that? Well, 90-degree angles are formed by opposite reciprocal slopes. So when we do the math, I'll kind of walk you through opposite reciprocal, but we need to calculate the slope of AC and CB. We need to calculate those two slopes to see if they're opposite reciprocals. So let's do that. So slope AC, okay? For this one, it doesn't say that I have to use the slope formula, so I'm going to use my grid lines and count rise over run. So from point C to point A, I went up 1 and right 2. So my slope is 1/2. Up 1, right 2. And my slope for BC right here, again, I can count rise over run. Well, I went down 1, 2, 3, 4, and right 1, 2. Okay, so we went down, what did I say, down 4 and right, oops, not negative, right 2. Okay, well, those definitely don't look like reciprocals at all, but if I reduced -4 over 2, I would get -2 over 1. Okay, so we're looking for opposite reciprocals. Okay, so remember, opposite reciprocals are same or different sign, opposite, different signs. So the first one, AC is positive, BC is negative. So they are opposite. Reciprocal means that the fraction is flipped. So what is on top is now on the bottom. What's on the bottom is now on the top. And in this case, yes, they are opposite reciprocals. They have different signs, and the fraction is flipped upside down. So opposite reciprocals, remember this, indicate that the lines are perpendicular. And if you remember what perpendicular means that it's a right angle. And in order to be classified as a right triangle, we need to have a 90-degree angle. We need to have a right angle. So one right angle will signify that, yes, this is a right triangle. Okay, so go through, and there are 2 other examples for you to do. So work through those and let me know if you have any questions.